In order to solve this identity, we're gonna have to do a few more things. First, I'm gonna try to factor this, and I'm gonna set it equal to 0. So that is 2 times the sine square of x plus 3 times the cosine of x, and I'm gonna subtract 3 from my equation. So now that I have my equation equal to 0, if we try to factor this, there's something in the way. We have a sine square and we have a cosine. We are gonna be in a lot more trouble if we try to factor this than if we standardize everything to either sine or to cosine. Luckily, we have this identity that allows us to write sine squared in terms of cosine as 1 minus cosine squared of theta. So that is what we're gonna be doing next. So instead of having sine squared, I'm gonna turn it into a 1 minus cosine squared of x. I did not alter the equation. I simply used an identity that allows me to have everything in terms of cosine. I'm gonna keep the rest as it is. And now I'm gonna multiply 2 times the 1 minus cosine squared. So that is 2 minus 2 cosine minus 2 cosine squared of x plus 3 cosine of x minus 3. Now, because we have this 2 and this minus 3, let's have it as 2 times the cosine square of x plus 3 times the cosine of x. And this is going to be minus 1. 2 and minus 3 gets you minus 1. And we're going to multiply everything by minus 1, just to have the equation with the first term as positive. I'm going to multiply by minus 1 and by minus 1, making my equation 2 times the cosine squared of x plus, in this case, minus, because we're multiplying everything by minus 1, and plus 1 equals 0. Now, this is a quadratic equation. If you remember, there was a time when you had quadratic equations as 2 times x squared minus 3x plus 1. And you could simply factor this by doing 2x and x. Luckily, we have a positive 1 at the end. And so if you do 1 and 1, you do end up with a positive 1 at the end, but we need this term to be negative. So the other possibility is to have a positive 1 as my last term, is to have 2x minus 1 and x minus 1. That's equal to 0. And if I multiply 2 times x, I get 2x squared. 2 times x times minus 1, I get minus 2x. Minus 1 times x, I get minus x. And minus 1 times minus 1, I get positive 1. So that is actually what I was looking for. So that means that I can use that knowledge in order to factor this equation as 2 times the cosine of x minus 1 and 2 times the cosine of x minus 1. Not exactly. I use the 2 minus the cosine of x minus 1 equals 0. Now, just like the previous problems, I can simply say that 2 times the cosine of x minus 1 needs to be 0. and the cosine of x minus 1 needs to be equal to 0. The cosine of x needs to be equal to 1/2 for the to find the solutions of the equation, and cosine of x needs to be also a 1. So we're going to locate every possible coordinate where the x is 1/2, positive 1/2. So positive 1/2 happens here, and positive 1/2 happens here, with the angles being pi over 3 and 5 pi over 3. Now cosine becomes 1 here at 0 and at 2 pi, but just consider that the 2 pi should not be part of your solutions. So my solutions are gonna be in order: 0 radians, pi over 3 radians, and 5 pi over 3 radians.